Okay, so last class we talked about special right triangles, and we started off with the radical review and simplifying radicals, and then we went into the special right triangles. So remember we looked at the bottom of our formula chart where it had the two different right triangles with the different patterns for 45, 45, 90 triangles, which was what we talked about last week, that bottom right triangle. Well, today we're going to talk about that other triangle, the 30, 60, 90 one that's on the bottom left. So if you look at your formula chart, you should see both of those. Remember, you get your formula chart on your tests and your quizzes and your skills checks. So you don't have to memorize the patterns for these, you just have to memorize how to use them. So, hopefully we've all been through the warm-up, looked at it, attempted it. This first triangle right here, example of a 45, 45, 90 triangle. So remember in 45, 45, 90, since the two angles are equal, that also means that the two sides are equal. If you look at your formula chart, it says x, x, and x root 2. So remember, if we know one of our legs, we know the other leg. So that means in this case, a should have been 8. And then we know that whatever our legs are, our hypotenuse is going to be that multiplied by root 2, or the square root of 2. So our hypotenuse, or C, should have been 8 root 2 inches. Sometimes we don't even have to do any math. The ones like that are pretty simple. We just follow the pattern. So, in number 2, it doesn't tell us immediately any angle measurements, so we might have been stuck if we weren't able to figure it out from there. But what we do know is that both of these sides are the same length because they both are labeled x. So if they both use the same variable, that means they have to be equal to each other. So in 45, 45, 90 triangles, we know that both of the legs are equal, so that means we can assume that this is a 45, 45, 90 triangle. Therefore, we know that the hypotenuse is 8 centimeters. And remember, according to our pattern, our hypotenuse is whatever the leg's value is multiplied by root 2. So in order to get that 8 right there, whoops, sorry guys. In order to get that 8 right there, we multiplied whatever the value of x is by root 2. So to get backwards to before it was multiplied by root 2, we can divide the 8 by the square root of 2. But remember, we can't leave our answer like that because we can't have radicals in the bottom of our fraction or in the denominator. So remember, we have to multiply by whatever we're trying to get rid of. In this case, by root 2 over root 2. Trying to write a dot, not working. So, on the top we get 8 root 2, and then on the bottom, root 2 times root 2 is the square root of 4, or just 2. Remember, we can't leave it like what we have here because it's not simplified all the way. We can still simplify that 8 and the 2 on the bottom because 8 divided by 2 gives you 4. So the totally simplified answer would be 4 root 2, and then we can't forget units, so centimeters. So both of those legs would have been 4 root 2 centimeters. Remember, we're not going to put anything in decimal form. We're leaving it in the radical form. That's the most simple. Okay. So on number 3. The length of the diagonal of a square is 12 centimeters. So we talked about last time what we can assume with squares, but just in case you forget, let's say, draw the picture. The length of the diagonal is 12. So that means that's 12 right there. Well, in a square, we know that the corners all make right triangles, which means when we do this diagonal and we split those two angles in half, so this angle automatically becomes 45 because we split the 90-degree angle in half. So we made two 45, 45, 90 triangles where that angle is 45 degrees and that angle is 45 degrees. So just kind of like we did on the last one, if we have our hypotenuse is 12, and 12 is whatever the two legs are, multiplied by root 2, to get backwards to the legs, we needed to divide 12 by root 2. So divide 12 by root 2. We can't leave that root 2 in the bottom because no radicals can go in the denominator. So then we have root 2 over root 2. On top, we can't really do anything because remember, we can only multiply things together that are either both under radicals or both outside of radicals. And then on the bottom, root 2 times root 2, we get 2. Then we have to simplify this further because we can divide this 12 by that 2. And we get 6 root 2 as one of the side lengths of our square. Because remember, we were solving for the side length. But be careful because that's not what it was asking for. It was asking calculate the area of the square. Remember, in find the area of a square, we just multiply the sides by each other, or that side value squared. So if one side is 6 root 2, then another side is 6 root 2. So we want to do 6 root 2 times 6 root 2. We multiply the things that aren't under radicals, so the two 6's, and that gives us 36. Then multiply the two things that are under radicals, so 2 times 2 is 4 underneath the radical, so 36 times the square root of 4, which is just 36 times 2. So our area of this square would be 72 centimeters squared. On this one, if you didn't do that last step, you might have just forgot to read what the question was asking you and just solve for the side link. So make sure you go back and look at what the question was asking you so that you don't get a question marked wrong just because reading errors. So that was our warm-up. Just kind of reviewing what we learned last time, make sure it didn't totally leave our brains. So now moving on to today's new types of triangles. If we're given this following equilateral triangle where each side measures 2 units in length, so B to C is 2, A to B is 2, and A to C is 2. Each of these are 2. So if we draw the midpoint of BC, remember it says draw, so it doesn't say construct, so we don't have to worry about getting out our compasses and doing the midpoint constructions like we used to do a while ago. So your midpoint would be right in the middle of that BC, remember, so somewhere right about there. We can kind of guesstimate, so just make sure you put it somewhere that looks close to the middle. And then we're going to label that point M. So, draw the median AM. So if I want to make the median, remember the median goes from the midpoint of a side to the vertice that's opposite of that. So if I'm going from M to the opposite vertice, I'm going to A. So that would be my median that I just drew. So if we want to find the angle measurements of the following. So angle ACM. Angle ACM goes ACM. So we're talking about this angle measurement right here. Well, if it's an equilateral triangle, we know that all the angles in an equilateral triangle are equal, just like all the sides are equal. So all the measurements of triangle angles add up to be 180, so each one of them would be 60 degrees. So since ACM was one of the angles of the original triangle, then we know that it's 60 degrees. Now we're looking at CAM. So CAM is this angle up here. So now we're talking about that angle. Well, originally the whole angle, so CAB, was one of the angles of our equilateral triangle, which we just said they're all 60. But when we drew this median, AM, we split that angle right in half. So now the angle is no longer 60 all the way across, it's just half of that. So CAM is going to be 30 degrees. And then lastly, we have angle AMC. So that's this one going straight down. That's formed by the median intersecting segment BC. And since we know that it's going straight down and it's perpendicular, it's crossing this at a right angle. So that means that this angle right there would be 90 degrees. Also, if you weren't sure if it was perpendicular, you didn't want to assume, remember that triangles are always going to have degrees that add up to 180. And we already said that this angle right here was 60, and this one's 30. So add those two together, that's 90. Well, what are we left with for the last one to be? 90 plus 90 is 180. So that tells us that this last angle is 90 degrees. I know it's been a while since we've done angles, so it might be kind of a refresher, but number 2 is asking us to use the Pythagorean theorem to find AM. When it says just find segment AM, it's asking us to find the length of that segment. So Pythagorean theorem, we're looking at just this right angle. So be careful on this one about which triangle we're going to talk about. We can't do Pythagorean theorem on the whole green triangle because that's an equilateral triangle. Remember, Pythagorean theorem only works with right triangles. So we're talking about A, C, M, those 3 points. We're going to ignore B for a second. So we knew that the whole side of each side of the equilateral triangle is 2. So this part down here from C to M is only half of that. So from C to M is only going to be 1. And that's one of the legs of our right triangle. So we have 1 squared. And then for our other leg, that's our median AM that we're talking about. Well, that's what we're trying to find. So we don't know that one yet. So we can just put plus B squared, because A squared plus B squared. That was 1. Kind of looks like an L. And then our hypotenuse, in this case, was one of the sides of our equilateral triangle, so we know that it's 2, because it was told to us at the beginning. So we have 1 squared plus B squared equals 2 squared. When we simplify that, we get 1, because 1 squared is just 1, plus B squared equals 4. Then we have to subtract that 1, we get B squared equals 3. And then that simplifies to B equals the square root of 3. Because we had to take the square root of both sides. And then remember, B was just our other leg, which was that median that we were trying to find. So AM right here that we're looking for is the square root of 3. And then whatever the units are, we'll just say units. So this is an introduction to the pattern. So if you look now at your formula chart, you'll see that the pattern says x, 2x, and x root 3. And you can kind of see how one of the sides was 1, so say that was x. Then the other side was 2, so that's your 2x. And then we have x root 3, so 1 root 3 was b in this case. So what would be the length of AM, which AM was our median, remember that second leg of that right triangle, if each side of the equilateral triangle was 4 units long? Well, let's draw a picture real quick since I took off the triangle. So if I have an equilateral triangle and each side is 4, and I'm looking for this median. That didn't look very straight. Looking for it right there. Just kidding. One more time. Okay. Pretend that that's straight. Okay. So, if we have this equilateral triangle, each side is 4. So, this whole thing is 4. And then 4 and 4. So, we're going to do Pythagorean theorem to find AM, and that's A and that's M. Then we would do just this part down here as one leg, and then that's our other leg, and then that's our hypotenuse. So we have, for this first leg, how long is it from here to here? Well, it's just half of all the way across, so we only want 2. squared as one of our legs. And then we don't know what this leg is yet. That's what we're trying to find. We're trying to find AM. So we have b squared equals the hypotenuse squared, so equals 4 squared. So we have 4 plus b squared equals 4 squared, which is 16. Then we subtract the 4. B squared equals 12. Take the square root of both sides. B equals the square root of 12. But remember last time we talked about the two different ways that we have to simplify radicals. Well, we have to simplify this square root of 12. We can simplify it further than what it is right now. So, I'm going to do the factor tree. If you wanted to find the biggest perfect square, that's okay too. But if I have 12, I split it into two factors. So let's just say I do 3 and 4. Well, 3 is already prime, so I can leave it alone. But I have to split 4 down further. So 2 and 2. And I have this pair right here. Remember, when I have a pair, that means they're like my socks. I fold them together. Now they become one. And I take it out of the drawer because you only wear pairs of socks when you have 2 of them. So that goes outside the drawer. So this would be the 2 on the outside, but we're left with this 3 guy right here because he didn't have a buddy to be with. So he stays on the inside. So then 12, the square root of 12 gets simplified to 2 square root of 3. So that was the length of this line right there. So if you look back again at your formula chart, the pattern, it works the same way. So if this triangle right here is my 30, 60, 90 triangle, where that one was 60, that one was 30, and that one was 90, then this side from here to here was 2. So that was like my X. This is 4, so that's my 2x because we multiplied this side over here by 2. And then this one is 2 root 3, so x root 3 because we multiplied the 2 times root 3. So it still follows the pattern. So all 30, 60, 90 triangles follow that pattern. So the triangles above, triangle ACM and triangle ABM, are examples of 30, 60, 90 triangles. So that's the second and last special right triangle that we're going to learn. So last time we did 45, 45, 90. Now we're doing 30, 60, 90. So you have this same pattern that we're about to write on your formula chart. So you'll have it in 2 places. Remember, you'll always have your formula chart. But just so you have it on your notes, go ahead and write it here too. So the side that's across from your 30-degree angle. So if you follow this 30-degree angle down, the side that's across from it is this side right here. That's always going to be the X in your pattern. So whatever number that is, we consider it X. And then your hypotenuse, so this one over here across from the right angle, is always going to be 2x. So that just means whatever length that this side was, or the one across from a 30-degree angle, the hypotenuse is always going to be that multiplied by 2. Always. In a 30, 60, 90 triangle. And then the side across from your 60-degree angle is always going to be x root 3. So whatever this side was across from the 30-degree angle, this side we get it by multiplying that by root 3. So similar to the x, and x root 2 from the 45, 45, 90, we just use this pattern in the same way. This time the values are just a little different. So we're going to practice a couple. So on this first one, what kind of triangle is it? Well, we have to figure that out first. So that's one of the skills that we're going to have to get used to doing, is determining, is it 45, 45, 90, or is it 30, 60, 90? Well, a couple of ways that we can just use quick hints, figure it out without having to spend too much time on it. When we see these markings, remember, if I was there, I would ask you guys what they mean, and hopefully someone could say it out. but these two markings tell us these sides are congruent. So if these two sides are the same, well, that's characteristic of a 45, 45, 90 triangle. Because remember in the pattern, it's x, and then x root 2. But in a 30, 60, 90 triangle, there's not two sides that have the same value. So in this case, we already could figure out a without having to do any work. If it's the same as 5, because they have the markings, then we know that a is also 5. And then we know that in a 45, 45, 90 triangle, the hypotenuse is just the legs multiplied by root 2. So we have b equals 5 root 2. And then in this case, we could just say units, because there are no units given. So a is that, b is that. So in the second one, it gives us one angle is a right angle, so 90 degrees. One angle is 60 degrees. So 60 plus 90, you could add them together and see what's left over. When you add these together, you get 150, which means this one would have to be 30. So now we know it's a 30, 60, 90 triangle. So now we're looking at that pattern on your formula chart that's on the bottom left triangle. So x, 2x, and x root 3. So remember, the one that we consider to be x is always the one that's across from the 30-degree angle. So in this case, our 30-degree angle is that angle. So which side is across from that? Well, we're looking at A. So A is x in the pattern. And then in the pattern, which one is 2x? Well, that's our hypotenuse. So in this case, that means 10 is 2x, because we know that the length of our hypotenuse is 10. It was given to us. And then B is the side across from the 60-degree angle, and in our pattern, that's x root 3. So if 10 is 2x, that's really the only one that we can start at to help us solve anything. In a equals x, we have two variables, so that's really not helpful to us. That just confuses us more. And then b and x, there's two variables again, so that doesn't help us. But if we have 10 equals 2x, we can figure out x by just dividing by the 2. So if we have 10 equals 2x divided by 2 and divided by 2, we get 5 equals x. So if 5 equals x, then what else do we know? Well, we know that a was equal to x, so now we know a equals 5. And then we know that b is x times root 3, and then we just figured out x is 5, so if we just substitute that in for that, 5 root 3. So a is 5, b is 5 root 3, and we're done. We did all that just by following the pattern, and we were careful to figure out or pick which side was across from the 30-degree angle, which side was across from the 60-degree angle, and start there. Remember, the pictures aren't always drawn to scale, so you got to pay attention to the angle markings and the numbers that you're given. So on number 3, we have those congruent markings again. So we have all these lines telling us that the sides are the same. So that means this figure is a square. And remember, when we split a square in half, we make two 45, 45, 90 triangles. Well, in this case, the value that we were given was the hypotenuse. And the hypotenuse is 8. Well, looking at your pattern, remember it's x, x, and then the hypotenuse is x root 2. Or whatever the legs are multiplied by root 2. So 8 is been multiplied by root 2 from whatever these were. So to go backwards, to undo the multiplication by the root 2, we had to divide it by root 2. So 8 divided by root 2. Then we multiply by root 2 over root 2, because we're going to get rid of this radical guy on the bottom. 8 times root 2 on the top just stays as 8 root 2. And then root 2 times root 2 on the bottom gives you 2. We can simplify that further to 4 root 2. So that would be x. Okay. So 4 and 5, we're still figuring out, is it 45, 45, 90, or is it 30, 60, 90? Well, in this case, we were given the 90 degree angle, and we are given the 60 degree angle. So we can assume pretty much from the beginning that it's not 45, 45, 90 when we're given an angle that's not 45 degrees. So we want to first find the sides that correspond with which side in the pattern. So that's the 60 degree angles and that's the 30 degree angle. So H is across from the 30 degree angle, G is across from the 60 degree angle, and then the hypotenuse is 2 root 3. Well, remember in our formula chart, the pattern goes where if this is the 30, oh, sorry guys, if that's the 30, and this is the 60, and that's the 90, then that one's x, that one's 2x, and that one's x root 3. So, in this case, the one that's going to be our smallest number is going to be h, and then g is going to be that times root 3, and then the hypotenuse is 2x. So this one gets kind of tricky because they throw a root 3 in there on the hypotenuse, but according to our pattern, the one that has the root 3 in the pattern is not the hypotenuse, is it? It's the one that's over here across from the 60 degree angle. That's okay, don't freak out, don't panic. So, the hypotenuse one is going to be equal to 2x. So, we have 2 root 3 in this case is our 2x. So, that just means that whatever the x was to begin with, it's been multiplied by 2 to give you 2 root 3. Well, if we just want to get back to what x was, if 2x is 2 root 3, to get back to just x, we can divide by 2 and divide by 2. Here that's going to cancel out, and then we get root 3 left over here equals x. And remember in our pattern that x is the one that's across from the 30 degree angle. So across from the 30 degree angle here is h. So we just figured out h is root 3. So h equals root 3. So now all we have to do is figure out g. Well, in the pattern, the 60 degree angle is x root 3, or whatever x is multiplied by root 3, and we just figured out x was root 3. So if we multiply root 3 by root 3, then we get 3 equals g. And remember, we did this just all by following the pattern. I know that one was a little bit confusing, a little bit complicated. Just don't get so confused when you see roots in the values that you were given to begin with. Don't automatically assume that this is the x root 3 in the pattern. Because just because it has a root 3 in it doesn't mean that it goes with this one. We have to look at what it represents and then solve backwards from there. So let's try another one. In this next one, we know again from the beginning that it's a 30, 60, 90 triangle because they already gave us this 60 degree angle right here. And this one should have a marking. I admit that one should have 90 degrees. And then that one would be our 30. So, if we have A and B like that, then okay, I lied, guys. The more I look at this one, I don't think it can be solved because we weren't even given any side links. So I just want you to go ahead and cross off number 5. We don't have to do it because there's not really anything we can do to it. So sorry, that was a mistake, but one less problem you have to do. Woohoo! Alright, number 6. So what is the length of a diagonal of a square with a perimeter of 20 feet? So it's a short sentence and a short question, but it has a lot of information in it that we have to use to work backwards. So we're looking for the diagonal of a square, and that square has a perimeter of 20 feet. So if a square has a perimeter of 20 feet, well, all sides in a square are equal, and there's 4 sides. So dividing that 20 up by 4 evenly, so 20 divided by 4, we would get 5 for each side. Now we're looking for the diagonal, so we want to go across it. Well, what kind of triangle did we just make? Well, when 2 of the legs of a right triangle are equal, so there and there, that's a 45, 45, 90 triangle. Remember, the only one of the 2 triangles that has 2 sides that are the same is the 45, 45, 90. Squares will always make 45, 45, 90 triangles. Don't forget that. So, we know that these 2 sides represent x and x in our pattern, and then the hypotenuse of a 45, 45, 90 triangle is just those legs multiplied by root 2. So the diagonal is just going to be 5 times root 2, which is just 5 root 2, and then it's a side length, so we have feet. And then we're done. So always draw a picture if there's not one, and it'll help you visualize it because it helps you kind of see where the sides are, what angle they're across from, etc. Especially with the 30, 60, 90 triangles, because those can get a little more confusing. Okay. So number 7. We got a lot going on in number 7. So first, let's just look at this triangle right here. So it tells us that this bottom angle down here is 30, and then this one is a right angle. So that leaves this one to be what? Well, 90 plus 30 is 120. And we know that all 3 add up to 180, so we're left with 60 right there. So this angle right here is going to be 60. So that means this left green triangle that I highlighted is a 30, 60, 90 triangle. So let's look at our pattern for 30, 60, 90. Don't get confused by this 45 here. It's not the side length of the side, it's the angle measurement of this. It will have degrees on a test, so you would know. It wouldn't be confusing like this. So that's this angle. So if this is 45 degrees, then we know that this over here is also going to be 45 degrees because this angle right here is a 90-degree angle because it's right next to another 90-degree angle, and that's a straight line. So remember, straight lines are 180 degrees, so if one of them is a right angle here, the other one's going to be a right angle. So this one's 90, and if we have a 90 and a 45, 90 here, 45 here, then this one has to be 45. So what we have going on in this picture is the green one is a 30, 60, 90 triangle. And then the red one is a 45, 45, 90 triangle. So what do we know about 45, 45, 90 triangles? Their 2 legs are always equal. So that side is equal to that side. And then the hypotenuse is those sides times root 2. So in this case, that tells us that A is equal to D. We know that. And then B is going to be those times root 2. But we can't really figure out A and D yet until we somehow figure out things about the 30, 60, 90 triangle. Well, let's look at the pattern for our 30, 60, 90 triangle. In a 30, 60, 90 triangle, the side that's across from 30 is X in our pattern. So in this case, A is the X of the pattern. The side that's across from 60 is X root 3. So in this case, 12 is going to be X root 3. And then we said a second ago A was X. I didn't write it down, but A was x. And then we know that the hypotenuse, which in this case is c, is always 2x. So c equals 2x. And remember, this x that I'm writing down is coming from our pattern, the one that's on your formula chart. So don't let the x part confuse you. So if 12 is x root 3, how can we just figure out what x is? Like, how can we get rid of this root 3 right here? Well, we can just divide by root 3. So if 12 equals x root 3 and we just want x, we divide by root 3 on both sides. Divide by root 3. Here it's going to cancel out. But on this other side, we can't have a radical on the bottom, so root 3, to get rid of that, we do times root 3 over root 3. We have 12 root 3 on the top, and then 3 on the bottom. Have to simplify that further. We get 4 root 3. And all that, remember, was just to find x. So x is 4 root 3. Well, what else do we know is equal to x? We wrote it right over here. A is x. So that means that a is 4 root 3. So now let's erase a is equal to x. We don't really need that fact anymore. So we know x root 3. We know x is 4 root 3. And then how do we figure out 2x? Well, if 4 root 3 is just 1x, to figure out 2x, we can multiply the 4 root 3 by 2. Well, 4 root 3 times 2. Remember, you just multiply the numbers that are either both under radicals or both outside of radicals. So in this case, the 4 and the 2, we get 8 root 3. So c is 2x, 8 root 3 is 2x, so that means c is 8 root 3. So now we figured out a and we figured out c. One thing that we're missing, I guess 2 things that we're missing, is b and d. Well, we said earlier, if we look up here, that a is equal to d. Well, we figured out a down here, so that means we already know d too. If a is the same thing as d and d is the same thing as a, then we can say that d is equal to 4 square root of 3. So now, if we look back, the only other thing that we're missing is b. And that's a part of our red 45, 45, 90 triangle. It's the hypotenuse of that. Well, looking at your pattern for 45, 45, 90 triangles, remember the 2 legs are x and x of the pattern. And then the hypotenuse is x root 2. So whatever these are, multiplied by root 2. Well, what are these? What are a and d? They're 4 root 3. See, they're both the same. So if I want to find out b, I need to multiply those by root 2. So 4 root 3 times root 2. Well, look, now I have 2 terms that have radicals. So remember, you can always multiply things that have radicals together. So I can multiply 4 root 3 and 2. So 4, and then we get 3 times 2 is 6. 4 root 6 is the hypotenuse of our 45, 45, 90 triangle, so it is b. So b was that, d was this, and then c and a were that. I should have put units on all those because they are side links. I could maybe squeeze them in those boxes. Just write u because we don't have any specific units. But remember, side links always get units. 4 root 6 units. So we solved for all the missing side links. That one was probably the most in detail or in-depth question that you've seen thus far. There's not one that complex center skills check today, but you do need to get more comfortable with those as we go into the quiz next week and then later on the test. So, in number 8, what shape do we have? It's not a triangle. Hopefully we can at least recognize that. Has 4 sides, and then 2 of them are parallel. It doesn't have the parallel markings, but it does have the 2 right angle markings. So these right angles, if they're 90 degrees, tells us that these lines, this one right here and this one right here, are perpendicular, which means we can assume that these are parallel. So, if these 2 lines are parallel, well, what 4-sided shape has 2 sets of lines that are parallel and then the other 2 sides aren't parallel? We call this trapezoid. So, trapezoid well, we can split this up where we do have some type of triangles, or at least one triangle. So let's split this shape up right, that was a little crooked, right here. So now we have that bottom red triangle going this way, and then the top green rectangle going this way. And we're trying to find the missing sides, so we're trying to find Y and we're trying to find W. So that bottom triangle, what kind of triangle is it? Well, it gives us the 60-degree angle measurement, which means that this other one right here would be 30, because we know that this one is a right angle. So, if we look at our pattern, the one that's across from 30, so right here is going to be your X. W is going to be your 2X. And then this right here is going to be your X root 3. And that's all just using the pattern for your 30, 60, 90 triangle. So, where can we start on this one? Well, are there any of these 3 sides that we can figure out from the beginning? Yeah, sure. We know that this side right here is 6 root 3 from this to this. Well, in a rectangle, opposite sides are the same. So right here, this side, the bottom green side of the rectangle, is also going to be 6 root 3. So that X root 3 in our pattern is 6 root 3. Well, in this case, it's kind of easy laid out to us because the pattern, they kind of look similar already, because our X root 3 of the pattern has a root 3 in its actual value. So if X root 3 is 6 root 3, then the root 3's stay the same, which just means that X is 6. So then that means over here, this part of the 30, 60, 90 triangle would be 6. So then, if X is 6, we're looking for 2X or W, so W would be 2 times 6, or 12. And then lastly, to figure out Y over here, which I kind of covered up with my wacky parallel line markings, is just the other side of that rectangle, the green rectangle. So to figure out Y here, we can just figure out what this one is here. Well, we know that the whole thing was 21 because it told us that from the beginning. This 21 right here represented the whole thing. And then just this red part of that whole side was 6. So if this whole thing is 21, and then from here to here 6, well, 6 plus what is going to give me 21? Well, we have 15 left over to get to 21, so that means that Y would be 15. So we have Y equals 15, W equals 12, and we're done. both units. So we're going to skip 9 real quick. I'll let you try and draw that one out. I'm going to do number 10 with you, and then you'll be turned loose. Y'all will be able to work on your homework over this up until the skills check at the very end. Yes, you do have a skills check. You'll be okay. Just make sure that you're paying attention to which kinds of triangles it is so you're using the right pattern. So, find the perimeter of a regular triangle. Well, we briefly talked about regular triangle last week in one of our lessons. Remember, regular shapes are just shapes that have all sides are the same. So kind of like equilateral. So if it's a regular triangle, then it is an equilateral triangle. So we have a regular triangle. You can just draw your picture however. Regular triangle. It's altitude. So what's an altitude? Well, even if you forget, think of the word altitude. In like the mountains, you talk about how high the altitude is. The altitude's just your height. So the altitude of that triangle is 4√3 centimeters. Well, remember, if it's an equilateral triangle or a regular triangle, all the angles in it that were the main angles of the triangle. So in this case, when we started with our green triangle, here to here would have been an angle. Here to here would have been an angle, and here to here would have been an angle. They're all the same, so they're all 60 degrees. That one's 60. This right here is the altitude, so it's 90. And then up here we just split this angle in half with our altitude. So that means this little sliver is a 30-degree angle. So now we're looking at which kind of the two triangles? Well, it's a 30, 60, 90. So the side that's across from my 30-degree angle, so right here, is going to be x. My hypotenuse, according to the pattern, is 2x. And then my altitude, which we already have, is x√3. So if 4√3 is equal to x√3 of our pattern, well, it kind of goes along with the pattern nicely, where we already have a √3 in the part of the pattern that has a √3 in it too. So that just means that 4 is x. Because if 4√3 is x√3, then the x will just come from the 4. So x equals 4. And then 2x up here would be 2 times 4. So we would get 8. So we're trying to find the perimeter of the original regular triangle. So that's that green triangle. Well, each of the sides of the triangle, so this right here was one of the sides. I'll go ahead and highlight them so we can see what we're trying to find the perimeter of. The perimeter of that side plus that side plus that side. So each of those sides is going to be 2x in length, which was we decided was 8. So 8 plus 8 plus 8, or 8 times 3, we get a perimeter of 24 centimeters. And then we would be done. So really, guys, these aren't usually too in-depth or involve too many steps. It's just a matter of setting it up correctly, making sure we're following the patterns the correct way. Okay, so now I want you guys to work on the homework over this up until it's time for the skills check. Y'all can work with each other. Then you can work with each other. There's the key posted online, so you can check your answers there to the homework key if you want to before the skills check. And we'll touch base back about this again when I'm back next week, so that way I can answer some of your questions that you may have that I'm not there to answer today. And I'm sorry. But you guys got this. You'll do great. Thank you, and work hard on homework and skills check, and have a good weekend.